Today discuss the topic graph theory. First of all, I am Divya, Assistant Professor of CSE Department. This topic is discrete mathematics. What is graph theory? Shall we start? These topics are covered. Definition, what is Hamiltonian, what is Euler, what is planar, what is graph coloring. These are topics are covered in the PPT. Introduction to graph. First of all, what is graph? Graph means collection of vertices and edges is connected to the one node. This is the graph. It means G of V comma E. V means vertices, E means edges. Mathematically, graph is ordered pair of V comma E. Each edge E of Ij is associated with ordered pair of vertices V of I comma V of J. See, E of Ij means edge of Ij is associated with the ordered pair of vertices means V of Ij V of I comma V of J means vertices of I comma vertices of J. See one example. This is the one vertex. 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 So, 4 vertices. V1 to V2 is the one edge. V2 to V4 is the one edge. V3 to V4 to V3 is the one edge. V3 to V1 is one edge. This is the one graph. It means what? V1 to V2 one edge, V2 to V4 one edge, V4 to V3 one edge, V3 to V1 edge. All edges are connected to the all vertices. This is the complete graph or undirected graph. So, this is the example of the graph. Go to next. See, this is the one example. See here V1, V2, V3, V4. 4 vertices. How many edges is used? V1 to V2 E1, V1 to V4 E2, V4 to V2 E3. And C means V1 to V2 one edge is connected, V1 to E2 one edge is connected. Here V1, V2, V3, V4. This is the 4 vertices. 4 vertices and 7 edges. Like E1, E2, E3, E4, E5, E6, E7. Then E1 equal to what? E1 equal to V1, V2. See, V1, V2. In short, we can represent G of this graph of V comma. V means vertices, E means edges. Where V equal to V1 vertex, V2 vertex, V3 vertex, V4 vertex. Here one self loop is there. E6. E6 means V3 is self connected to the graph. See, E equal to E1 edge, E2 edge, E3 edge, E4 edge, E5 edge, E6 and E7. This is the one example of the graph. Next, this is the one definition of graph. It means dot, links, edges and or arcs. It representation of graph. G of V consists of vertices denoted by V. Edges is denoted by E. E of G. There are number of types of graphs like directed graph, undirected graph, null graph. Directed, undirected, null graph, complete graph, incomplete graph, cycle, wheel. There are so many types of graphs. See, first graph. What is directed graph? Directed graph means, see, this is the U vertex, this is the V vertex. U to V is connected to the direct. It means direction. It means direction. Ordered pair of vertices represented as U comma V is directed from the vertex U to V. It means what? U to V, one edge is connected. One edge is connected means U follow the V. V not follow the U. This is the directed graph. What is undirected? As undirected graph means there is no direction. U follows V, V follows U, vice versa. This is the undirected. Directed means only the direct to U to V, not V to U. This is the directed. Undirected means U comma U to V, V to U. This is the undirected graph. See the definition. Ordered pair of vertices represented as U comma V is directed from the vertex U to V. What is undirected? Undirected pair of vertices is represented as U comma V. This sense of treats both end vertices interchangeably. Interchangeably means what? U followed by V, V followed by U. This is the undirected graph. Go to next. Loop. What is loop? What is loop? A loop is an edge whose endpoints are equal to an edge. It means U is self loop of U. U means U self, itself U. This is the loop is represented as U comma U. U comma U means what? U. U is a self loop of U. Next, multiple graph, multiple edges. Two or more edges is joining same pair of vertices. Means, see one example. A is the one vertex, B is, wait a minute, B is the one vertex, C is the one vertex, D is the one vertex. So A to B, B to D, D to C, C to A. This is the normal graph or complete graph. What is multiple edges? A is connected to D. Okay? A is connected to D. Okay, this is the one multiple edges example. Two or more edges is joining the same pair of vertices. A to D, A to B, A to C, A to D. A is how many vertices are following? A to B, A to D, A to C. This is the multiple edges. Next, simple undirected graph. See, before I tell what is undirected graph. Undirected graph means, see example, U followed by V, V followed by U, U followed by W, W followed by U, W followed by V, V followed by W, vice versa. U is the one vertex, V is the one vertex, W is the one vertex. Okay, U is no direction between the V. It means U is vertices of V, V is vertices of W, edges of W, W edges of U. Consists of V, non-empty set of vertices. Non-empty set of vertices means what? No direction is between the u comma v. Is set of unordered pairs of distinct elements of v edges is undirected. Representation of one example. G of v comma e. V equal to u v w. U v w what? Vertices is denoted by v. E equal to u comma v. E edges is followed by u comma v, v comma w, u comma w. This is the simple undirected graph. Next, multigraph. What is multigraph? See, E, this is the U, is followed by E1 is the one edge, V is followed by U is connected to the E2 is the one edge, V2 is connected to the W vertex is connected to the edge E3. Multigraph means consists of set of vertices V, set of edges E, function f from E to U comma V, U not equal to V. This edge E1 and E2 are called multiple or parallel edges. It means what? This is U and V is followed by two edges E1 and E2. This is the parallel edges. E are also known as multiple graph. This is the multiple graph. Representation of example V. V means vertices. Vertices, how many vertices? U, V, W. Edges E1, E2, E3. This is the multigraph, one type of graph. Next, pseudograph. Pseudograph means what? Multiple edges means parallel edges are one undirected edge and one self loop. This is the pseudograph. Pseudograph is combination of loops and parallel edges and undirected graph. This is the pseudograph. Here see example. This is the parallel edges. This is the one undirected line. This is the one self loop. W is itself W. This is the E4 edge. This is the E1 edge. This is the E2 edge. This is the E3 edge. V equal to how many vertices? U, V, W. E equal to how many edges? E1, E2, E3 and E4. How many edges? E4 edges. This is the pseudo graph. I think understood. Next, weighted graph. What is weighted? Weighted means before one example, this is the pseudo graph. Pseudo graph means there is no weight, means U to V how many weight, U to V how many weight, V to W how many weight. See, weighted graph means each edge or each vertex are both associated with some vertices. This is the weighted graph. V1 to V2 no weight, V2 to V3 1.5 weight, some weight, V3 to V4 1.7 some weight. It is denoted to some weight, is calculated to the weight values, weighted values. So, weighted graph is first considering the V1, V2 to V3, V3 to V4, V3 to V4 to V2 and next V2 to V1. This is the graph of weighted graph. What is null graph? Null graph, it is simple meaning is that no vertices and no edges connected to the graph. This is the null graph. Definition. See definition. If the edge set of any graph with n vertices is an empty set, then the graph is known as null graph. See, this is the one graph, this is the one null graph, this is the one null graph. Here, no vertices, no edges is connected to the vertices. This is the null graph. See, null graph is over. Next, definition of graph. Already. Next, directed graph. Directed graph means you all already see the undirected graph. Undirected graph means no direction between two vertices. Here, directed graph means G of V comma E set of vertices V and set of edges E. That is the ordered pair of elements of V. See, U is directed to the V. V is directed to the W. W is directed to the U. See, this is the one example of directed graph. U is following the V. V means what? V is followed by U. W is followed by V. W is followed by U. This is the directed graph. Example C. Example G of V comma E. V equal to U V W. E equal to what? U comma V is the one tuple. V comma W is the one pair. W U is the one pair. It because calculating the directions. Okay, this is the directed graph. Next, directed multigraph. As already told that directed graph is connected to the two parallel edges. U is directed to the V one edge. U is directed to the V one edge, E1 and E2. Next, V vertex is connected to the W. E3 is the one edge. W is self loop of itself. It means itself of W. This is the E4 is the one edge. C consists of set of vertices V, set of edges E is function from E. E means edges. U comma V or U comma V. U comma V is how many parallel edges? 2. E1 and E2. Multiple edges f of E1 equal to f of V2. Okay, representation of example. How many vertices? U, V, W. How many edges? E1, E2, E3, E4. This is the directed multigraph. See, this is the tick table of graph type. See, first example, simple graph. Simple graph, edges undirected, multiple edges, no, it is not accessed to the multiple edges. Loops allowed, no. This is the easy to understand this table. How to connect it to the undirected graph, how many multiple edges are allowed, what loop is there, yes or no. Next, multigraph. Multigraph is undirected graph. Multigraph edges is allowed, yes. Loops are allowed, no. Pseudograph. Pseudograph is the undirected graph. Multiple edges are allowed. Already see the example. S. Loops are allowed, S. What is directed graph? Directed graph means direction is one edge to one edge is the directed. Next, multiple edges are not allowed. Loops are allowed. What is directed multigraph? This is the directed. Multiple edges are allowed. At the same time, multiple loops are allowed. This is the easy to understand this table. What is simple graph? What is multigraph? What is pseudograph? What is directed graph? What is my directed multigraph? See clear? Next. What is undirected graph? Already told. What is directed graph? Already see examples. What is complete graph? See, what is complete graph? Complete graph means, see, this is the example. One edge to one vertex to one vertex is connected to the one edge. This is the complete graph. See, V1. See, this is the V1. This is the V2. This is the V3. Okay. V1 to connected to V2. V2 to connected to V3. V3 to connected to the V1. This is the complete graph. What is incomplete graph? Means, see, V1, V2, V3. Here this is the V1, V2, V3, but V1 to V3 no edge will be connected. So this is the incomplete graph. See, the definition is the simple graph that contains exactly one edge between each pair of distinct vertices. It means this is the one vertex, this is the one vertex, this is the one vertex. V1, V2, V3. Here all vertices are connected to the all edges. This is the complete graph. See, this is the incomplete graph. See, this is the complete graph. V1, V2, V2 to V3. All multiple edges are allowed. One cycle is allowed. But all vertices are connected to the all edges. K1, K2, K3, K4. K1 is the completed graph, K2 is the completed graph, K3 is the completed graph, K4 is the completed graph. Next, cycle. What is cycle? See, this is the one cycle. One cycle means this is the V1, V2, V3. Tell me the path. V1 to V2, V2 to V3, V3 to V1. This is the one path. Here V1, V2, V3. Tell me the V1, V2, V3. V3 to V1, where is the path? So, this is the no cycle. Okay, this is the cycle of the graph. It consists of n vertices V1, V2, V3, Vn and edges V1 to V2, V2 to V3, V3 to V4. V1 minus 1, V1. This is the C3, C4 is the cycle graph. All vertices are connected to the all edges. This is the cycle. This is the no cycle. Next, wheel. What is wheel? Wheel means here this is the one V1, V2, V3. This is the one wheel. V4 is the one vertex. Is adding additional vertices Cn is connected to the all vertices to the new vertex by new edge. Means this is the new vertex. This new vertex is connected to the all vertices. Is connected to the V1, is connected to the V2, is V4 is connected to the V3. This is the one wheel. See, this is the one example. A, B, C, D. E is the one new vertex. E is connected to the A, E is connected to the B, E is connected to the D, E is connected to the C. This is the graph of wheel. Clear? Next, bipartition graph. This is the most important graph in the graph theory. See, this is the V1 is the one vertex, V2 is the one vertex. Here V, comma E. Okay, V is partitioned into two, V1 and V2. Okay, V1, V vertex is connected to the, this is the V. V is connected to the V1 and V2. Okay, V1 graph, V1, V2, V3, V2 graph, V4, V5 vertices, V5 and V6 vertices. It means there is connected to the partition into two disjoint sets. Two disjoint sets means what? V1 is the one disjoint set, V2 is the one disjoint set. V2 such that every edge in the graph connected to the vertices of V1 and vertices of V2 means what? V1 vertex is connected to the V2 vertex V4. V2 vertex is connected to the V5 vertex. V3 connected to the V6. But one condition, no connected to the edge between V1 to V2, V2 to V3. No edge is connected to the V1 to V4 to V5, V5 to V6. This is the bipartition graph. V1 vertices how many? V1, V2, V3. V2 vertices V4, V5, V6. No edge is connected to the between V1 vertices. No edge is connected to the between V2 vertices. This is the bipartition graph. Next, some operations are there. Here two operations I am explaining. One union, second one intersection. What is union? Union means this is the union of G1. G1 means this is the G1. G2 means V2, E2, and G1 union G2. Okay. Sorry. V1, E1 and G2 of V2, E2. This is the simple graph with vertex V1 and E2 and edge set of E1 union E2. So G1 union G2, combine the two graphs. This is the G1 union G2. See, this is the one vertex A, B, C, D, E. A, B, C, D. Here one edge is not connected to the B to C. Here one edge is not connected to the C to D. Okay. See, this is the G1 is the one graph, G2 is the one graph. These are vertices how many? 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. Here B2 is not connected to the C. B vertex, C vertex is connected to, not connected to the D. So G1 union G2 means this is connected to the A, B, C, D, E. So here combine the two graphs. B to C is connected, C to D is connected. This is the one graph of union graph. Next, what is intersection? What is intersection means? This graph is intersected to the this graph means minus, means substitution the one graph to second graph. Here G1 is the one graph, G2 is the one graph. All nodes is divided, means removing the common vertices. It means remaining what? 1 A, B, C. It means a vertex set of V1 intersection V2 and edge set E1 intersection E2. So common vertices, common edges is removing, remaining vertices will be printed. This is the operation of graph. Already bipartition is over. See one example. G1 is bipartition. This is the no bipartition graph because there is no way to partition into the two sets, so that there are no edges with both endpoints in the same set. Here this is bipartition, means V1, V2, V3 is the one partition. V6, V5, V4 is the one partition. See, this is mapping V1, V5, V3, V6, V2, V4 is divided to the two partition. This is the V is divided V1, this is divided V2. This is S because can display G2 like this. Here G2 is the bipartition graph, G1 is the no bipartition graph. Subgraph. Subgraph means this is the graph G, three vertices. G of V comma E, H of V dash E dash. V dash E dash means this is the one edge. U comma V is the one edge. H1 and H2. Here example V equal to U V W, E equal to U comma V, V comma W, W comma U. So H1 is the one subgraph, H2 is the one subgraph. Next, matrix representation. Matrix there are three types. First one is incidence matrix, second one is adjacency matrix and adjacency list. So first we discuss incidence matrix. What is incidence matrix? Most useful when information about edges is more desirable than information about vertices. This is the incidence matrix. Incidence matrix is undirected graph. Undirected graph. Undirected graph. It is connected to the no directions. It means this is the one incidence table. This is the V, U, W is the vertices, E1, E2, E3 is the edges. See this table, V2 to E1 is going one edge, S, E1. So 1, put into 1, V2, E2, no edge will be connected to the V2, E2. So put into 0. Okay. Next, V2 to E3. V2 to E3, no edge will be passed, yes, will be passed. E3, put into 1. Okay. Next, U means U1 vertex will connected to the E1 and E2. So, E1 put into 1, E2 put into 1. See, U2 to E3, no edge will be connected. So, 0. Next, W is the one vertex, will be access to the E2 is 1 followed, E3 is 1 followed. W to E1 is not followed. So 0, 1, 1. This is the incidence matrix. Okay. Next, adjacency matrix. Adjacency matrix. Incidence matrix is supported to the undirected graph, but adjacency matrix is supported to the undirected and directed. So in n into n matrix will be given to the adjacency matrix. It makes easy to find the subgraph and reverse graph is needed. So in case easy to understand the undirected and directed. See, A of ij 1, if V ij is edge of G 0 is otherwise. It is the undirected graph. This is the directed graph. See the representation of adjacency matrix. See the one example. This is the one example. Undirected graph G of V comma E. Here calculating the vertices to vertices. No vertices to connected to the edges. See, this is the vertex, 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 this is the vertex. See, V2 to V, no, 0. V2 to U, S will be connected. So, put into 1. V2 W, S will be connected. So, V2 to W. Next, U2 to 1, S will be connected. U2 to 1, 1. Next, U2 to W is connected as 0. This is the adjacency matrix. Here see the over W. W is put into V1 and V and U. Okay. 1, 1, otherwise 0. No connected to the vertices, so put into 0. This is the adjacency matrix. This is the directed graph. Adjacency matrix is supported to the directed and undirected graph. Before see the undirected, see the directed graph. As directed graph is same as vertices to vertices is connected. So U2 to first will starting the V. V to V 0, V to U 1, otherwise 0. Only followed by one vertex is the undirected graph. So 1. V2 to W, W to W followed by V, but V not followed by W. So V is 0, V to W 0. Next U is 0, W is 0 because U2 no directed to the V, 0. U2 U2U not connected to the self loop, so 0. U2W, one edge is connected, so 1. Next W, like as this is the directed graph. Okay. Third type, adjacency list, is only list of vertices. U, see, each node vertex has list of which node vertex is adjacent. Undirected graph, this is supported to the undirected graph. See, U2 how many adjacents will be passed? U2 V comma W. So this is the list, one list. V vertices, how many vertices will be followed? U W. So U W. W vertex is followed by how many? U V. U comma V. This is the example of adjacency list. Okay. Next topic is isomorphism. This is the interesting and most important topic of graph theory. Okay. First we'll discuss definition. What is isomorphism? Two graphs are, what is an isomorphism? Isomorphism means two graphs are equivalent to the isomorphic, is the identical behavior in terms of theoretic properties. See, let me explain it simple way. There are connected to the two graphs, G equal to VE, G dash equal to V dash E dash. Here three conditions will be accessed. First one, same vertex must be accessed to V1. Same edge, both graph contains same vertices, both graph contains same edges, both graph contains same degree. This is the isomorphism, means G1 equal to G2. Okay, one to one correspond between their vertices, between their edges, such that incident relation will be preserved. It is denoted by G1 graph equal to G2 graph. See this example. G1 is the one graph, G2 is the one graph. See, this is the conditions of graph. Same number of vertices means 1, 2, 3, 4. A, B, C, D is the two vertices. A, B, C, D is the four vertices. These are the four vertices. These are the four vertices. So this condition will be satisfied. Next, same number of edges. How many edges are there? 1, 2, 1, 2, 2, 1, 2, 2, 1, 1, 2, 2, 3, 1, 3, 2, 4, 1, 4, 2, 1, 1. Overall, how many edges? 4. Here, 1, 2, 2, 1 edge, 1, 2, 2, 1 edge, 1, 2, 3, 1 edge, 3, 2, 4, 1 edge, 3, 2, 1, 1 edge. How many edges will be there? 4 edges. So, this will be satisfied. Next, same degrees. Degree means what? Here, vertices, how many edges will be followed? 1 and 2. So, one vertex, 2 degree. Next, 2 vertex. Second vertex, how many degrees will be there? 2. Third vertex, how many degrees will be followed? 2. Fourth vertex, how many degrees will be followed? 2. This is the G1 graph. Okay. Next, G2 graph. See G2 graph. This graph, how many degrees will be followed? 1, 2. This is the one edge, this is the one edge. See, second vertex 2. This is the one followed, this is the one followed. Next 3. Third vertex. Third vertex, how many edges will be followed? 1, 2. Next, fourth vertex, how many edges will be followed? 1 and 2. So, this is also the same. So, this is the isomorphism graph. Isomorphism graph means what? G1 equal to G2. Okay, 1, 2, 3, 4 is the one vertex. A, B, C, D is the one vertex. All edges is same number of vertices will be done. Same number of edges will be satisfied. Same degree of vertices will be satisfied. This is the isomorphism. This is the one graph of isomorphism. Okay. U1 equal to V1, U2 equal to V4, U3 equal to V3, U4 equal to V2. So, G1 equal to G2. Next, Euler circuit, Euler path, Euler walk, Euler train. There are two types, Euler graph and Hamiltonian graph. First, explain Euler graph. What is Euler graph? What is Euler graph? What is Euler graph? Euler graph say one condition. What one? Euler graphs one condition. It means what? Visit the, you see the example, visit the edge exactly once, means visit the each edge exactly once. This is the Euler graph. Start to the end vertex is different. Vertices are different. It's no problem. But each edge visit the only once. This is the Euler graph. Euler graph means is the path each edge precisely once. Means what? Each edge must be visit to the once. If such path exists, then the graph is traversable. What is Euler cycle? Euler cycle is also known as Euler circuit, Euler true. Is graph, each edge is precisely once. In cycle exists, the graph is called. In case one cycle will be exist, this is the Euler circuit. This is the path between first visit to the A connected to the B edge. Okay. Next B is connected to the E edge. So these two edges will be covered. Next E is connected to the edge of D vertex. So D is also covered. Next, this will be covered now. D is vertices will be repeated, but edges is exactly once will be accessed. So D to B. Next, D to B means this is the one vertex will be repeated. Next B to A. Next A to D. D is the repeated vertex. D to C. C to A. So A is the repeated vertex. So vertices will be repeated, but edge visit exactly once. So here all edges will be covered. This is the one path. See, A to C, C to D, D to E, E to B, B to D, D to A. How many vertices will be repeated? A and D. A and D. these vertices will be repeated. There is no problem, but edges will be visited only once. This is the Euler graph. See, this is the theorem of Euler theorem. Is same as R degree. Next, Hamiltonian graph. What is Hamiltonian graph? Here, Euler graph, each edge is repeated exactly. Hamiltonian graph means each edge is exactly repeated once. But Hamiltonian graph condition is what? Each vertex exactly once. This is the Hamiltonian graph. Euler graph, each edges exactly once. Hamiltonian graph, each vertex is visited to the exactly once. This is the Hamiltonian graph or Hamiltonian path. What is Hamiltonian circuit? Vertex tour. It means it visits each vertex exactly once except the starting vertex. Starting vertex means this is the one example, no? A, B, C, D. No vertices will be visited one or more times, but except starting vertex. Starting vertex visited to repeated means A is visited to the B vertex, B is vertices to C, C is vertices to D, D is vertices to A. A is repeated vertex, but there is the no problem. Why? Because here condition is what? Here condition is what? Except for the starting vertex, which is visited once the starting and once again at the end. There is no problem of starting vertex. This is the Hamiltonian cycle. A graph contains Hamiltonian path is called traceable graph. A graph that contains Hamiltonian circle is called Hamiltonian graph. Any Hamiltonian graph is converted to the Hamiltonian path. Hamiltonian circuit is satisfied. This graph is Hamiltonian graph. This is the Hamiltonian. See this example. This is one as Hamiltonian path. Hamiltonian path means here put into V1 vertex, V2 vertex, V3 vertex, V4 vertex, V5 vertex. Okay. V1 is connected to the V2. V2 is connected to the V3. V3 is connected to the V4. V4 is connected to the V5. Okay. This is the path. Okay. Next. But no Hamiltonian tour. Hamiltonian tour means what? This is the visited to the all vertices. All vertices will be visited? No, na. V1, V2, V3, V4, V5, set of vertex V6, V1. This is the no tour of the Hamiltonian graph. See this example. This is one as the Euler tour, but no Hamiltonian path. Euler tour means what? All edges is repeated exactly once. V5, V6, V7. Okay. V1 to V2, V2 to V3, V3 to V4, V4 to V5, V5 to V6, V6 to V7. See, V1 to V2 is the one edge. See first explain Euler tour. V1 to V2 is the one edge, V2 to V3 one edge, V3 to V4 one edge, V3 to V5 one edge, V6, V7. Here vertices will be repeated but edges will not be repeated. So V7 to V3 to V7 will be repeated, V7 to V1. So there is no edge will be repeated one or more digits. Here all edges will be repeated only once. This is the Euler tool. What is Hamiltonian path? Hamiltonian path means no vertex will be repeated except starting vertex. See the example: V1, V2, V2, V3, V4, V5, V6, V3. See, one vertex will be repeated. So this is the no Hamiltonian path. Okay, Hamiltonian path may not be accessed because this is the V3 is the will be repeated. Next topic is planar graph. What is planar graph? What is planar graph? A graph, its simple meaning is a graph is without crossing any edges. Without crossing any edges is called planar graph. Planar graph means what? G can be drawn plane with edges intersecting only at vertices of G. Such a drawing G is called planar graph. Planar graph means what? Here this is the non-planar graph because here one edge will be crossed to the another edge. This is the not planar graph. Planar graph, non-planar graph is converted to the planar graph. Means here V1, V2, V3, V4. Okay. Here V1, V2, V3, V4. Edges E1, E2, E3, E4, E5, E6. Okay. Here this crossing edge will be rectified to the this way. Okay. So this is converted to the planar graph. Planar graph means no without any crossing edges is called planar graph. K1, K2, K3, K4 is the planar graph. Kn greater than 4 are non-planar graph. No crossing edges with one graph is the planar graph. See, this is the one example. Here one line will be connected to the another line. So this is the non-planar graph. So this is the planar graph. Planar graph means no edges will be crossed. Okay, no edges will be crossed. This is the planar. This is the planar. Here, this is the one example. Here, V1, V2, V3, V4, V5, V6. Here is divided to the two graphs, V1, V2. This is the one theorem. This is the one example. Planar graph is connected to the this way. V minus E plus R. V means what? Number of vertices. E means what? Number of edges. R means number of regions. Here, one example, this is the one region, this is the one region, this is the one region. Okay, this is the V1 vertices. How many vertices? 1, 2, 3, 4. So here V equal to 4. Edges how many? 1, 2, 3, 4, 5 and 6. How many edges will be there? 6 equal to 6. How many regions will be there? R1 is the one region, R2 is the one region, R3 is the one region. Next, outer region is R4. So, how many regions will be there? 4. So, this theorem, first theorem condition is what? V minus E plus R. V, vertices how many? 4. V minus E plus R equal to 2. This condition will be satisfied. This is the planar graph. Okay, so 4 minus 6 plus 2, how much? 2. This is the theorem of planar graph. Okay, this is the planar graph on example. Next, interesting and easy topic of graph coloring problem. I think this is most covered to the graph theory problem. Thank you.